So this question is all about trigonometry. We've got an isosceles triangle. Two sides have got length 1. The isosceles triangle split in half with a right angle, and each of the angles labelled x are the same. And in part A of this question, we're asked to find an expression for BM. What I would do here is I would draw out the left-hand triangle. We know it's a right angle triangle. We can label the base of the triangle BM. The hypotenuse is 1 and the angle at the top is x. Now we've got a right angle triangle, and straight away, because we've got one angle and two sides, we should be thinking about SOHCAHTOA and trigonometry. So I label opposite adjacent hypotenuse. I write out SOHCAHTOA, and I decide which bit I'm going to use. I've got O that I want to find and H that I have, so the SOH, the sine section, is the bit to use. So the formula is that sine x is equal to the opposite, which is BM, divided by the hypotenuse, which is 1. Now dividing by 1 doesn't really do anything, so we've got an expression for BM in terms of x, which is what we're asked for. BM is equal to sine x. Now in part 2, we're asked to write an expression in terms of x for BC. This is actually very easy, because the length BC is clearly twice the length BM. So BC is just 2BM. Now we already know what BM is, it's sine x. So BC must be 2 lots of sine x. Now for part B, we need to change tack completely. We are looking for an expression for BC squared in terms of cos 2x. Now here we need to look at the whole triangle with BC. But where does this 2x come from? It comes from the angle at A, which is just x plus x, which is 2x. Now because we don't have any right angles in this triangle, we need to label it in a different way, using little a, little b and little c, opposite the angles big A, big B and big C. And because we've got cos, we're going to use the cosine rule, which says that a squared is equal to b squared plus c squared minus 2bc cos of capital A. Now if we substitute in what we know, A in our diagram is BC. B is 1, C is 1, and A, capital A, the angle, is 2x. Now if we simplify this down, we end up with BC squared is equal to 2 minus 2 lots of cos 2x. And that is our expression in terms of cos 2x for BC squared. Now the final part of this question looks completely different to what we've just been doing. We need to show that cos of 2x is equal to 1 minus 2 lots of sine x squared. But from part B of the question, we know that BC squared is equal to 2 minus 2 cos 2x. And from part A of the question, part 2 of part A, we know that BC was equal to 2 sine x. Now what we're interested in is BC squared. So if I square the left hand side, I have to square the right hand side. Now to square this properly, I need to square the 2 and I need to square the sine x. So I get BC squared is equal to 4 times by sine x all squared. Now these two BC squareds are both the same, so the things that they are equal to must themselves be equal. So that means that 2 minus 2 cos 2x must be equal to 4 lots of sine x all squared. Now we can see this is quite close to what we're aiming for. To get there, the first thing I'm going to do is divide everything by 2. And when we divide by 2, we don't divide the angle by 2. The angle doesn't change. But the coefficients all get divided by 2. We're then going to add cos 2x to each side. And we're going to end up with 1 is equal to 2 lots of sine x all squared plus cos of 2x. And then to make it look exactly like what we're asked for, we're going to subtract 2 lots of sine x squared from each side. So I end up with 1 minus 2 sine x all squared is equal to cos of 2x. And that's exactly what they've asked us to show in part C of this question.